So we're still looking at hypothesis testing for continuous random variables only. If you think back to last time, we had a 6-point plan, really, of things to go through for every hypothesis test we came across. We had 6 steps that we would go through. So the next example we're going through, example number 3, it says x follows a normal distribution, mean 185, variance 15 squared, and a sample of 25 items is taken, and the sample mean, x bar, is 179. We have to test at the 5% level whether or not the mean has fallen. So basically, do we still believe the population mean is 185, or has the population mean fallen? So what was step 1 of any hypothesis test?
Write down the null.
Write down the null and alternative hypothesis, yeah. So H0 is nothing exciting has happened, it's always just the status quo. So in stats language, mu is still 185, and in English, the mean has not fallen, or the mean is unchanged. Well, here it actually has not fallen. So, after our null hypothesis, we do our alternative hypothesis, H1, and we're told what that is in the question. The mean has fallen. So that is mu is less than 185. The mean has fallen. And also in step 1, although I don't think it was written down as it was in brackets in our bullet point for step 1. What do we also write down at this point, or decide or observe at this point? 1 or 2 tail test, yeah. That symbol there tells us this is a 1-tailed test. It's a 1-tailed test because it's not a not equal to sign, it's a less than sign. So, step 2, decide on the significance level of the test. We are told we are working at a 5% significance level. Step 3, calculate a critical value in a critical region. I think this is a good point always to do a drawing. If you draw your normal curve, under the null hypothesis, our mean is 185. We're doing a 5% 1-tail test that it's fallen. So our critical region is going to be to the left of this C value, where this shaded area here is going to be 5%. And we need to find out what this C value is. And then we're going to look at our test statistic, and our test statistic is the 179. If the 179 is where my pen is pointing, which hypothesis will we accept? H1. If my pen... If the test statistic was anywhere over here, we would accept H0. So the next thing we need to do then is work out the test statistic. Well, we're using the distribution of x bar. X bar is normal, mu, sigma squared over n. That's the distribution of x bar from the central limit theorem. So in this question, we're going to be basing our x bars on 185, because that's what's in the null hypothesis. Sigma squared is 15 squared. We had a sample of 25. So that's our distribution of x bar. And we want to find the value of C. So we want to find the probability that x is less than C is going to be 5%. And then we've been putting that straight into a phi notation. So can anybody tell me what's going to go inside this phi bracket?
C.
C, yep.
C minus 185.
Minus the mean, yep.
Over square root of 15 squared equals 25.
Yeah, that's right. That is square rooted, put down there. 5%. Okay. What's the next thing we do then after we've got that written down?
Anti-phi.
Anti-phi, yeah. Which means on the left hand side we just write that down again.
Is that spelled PH? It's spelled TH.
PHI, yeah, phi. And on the right hand side I anti-phi 0.95. Now that's anti-phying something small. How do we cope with anti-phying something small?
T. minus with a minus outside.
1 minus that. We antify 1 minus that and put a minus in front of it. So we will do minus anti-5 0.95. So if you look in your green books, you can look at the row at the bottom of that page, and it will be there because it's one of those common values. Okay, 0.95, 1.645. You'll be remembering that soon. So we're getting here minus 1.645. Is everybody happy with what we've done up to here? Am I going the right speed? Not too fast. Okay, now we rearrange that equation to find out what C is. Now I think Billy's already done this. Billy, what did you work out that C was when you rearranged that?
I think I've done it wrong. No, I haven't. C was 180.065.
That's correct.
Oh.
Okay, that is correct. So that is what our C value is. Our critical value comes out to be that. If you just rearrange that equation, solve that equation, no need to do it now. I'm just reproducing the diagram from earlier. Okay, so our critical value is 180.065, which is what that's supposed to say there. Our critical region is everywhere to the left of that, and our sample mean was 179. So our sample mean at 179 comes in here. That was our test statistic. It's in the tail, which is unlikely to have happened by chance. I mean, we've said there's only a 5% chance of it being in that tail. So we are going to, as we said earlier, reject H0 and accept H1. So, the final bit, writing down our conclusion. You could say in an A-level exam, as X bar is in the critical region, i.e. it's less than 180.065. See, we reject H0, which means we have no choice other than to accept H1, and then you need to give a wordy answer to that. The mean has fallen. If you wanted to give a really proper example, proper answer, in front of the mean has fallen, we would say, using a 5% significance level, a 5% significance level, we will conclude that the mean has fallen, if you want to be really, really precise in your wording. Any questions, comments about that one?
What happens if C is like exactly on the boundary of critical like that?
Then I don't think that would happen in an A-level question, because it's, and you could go either way really. Yeah. Right, I'll stop that video there and we'll move on to another example in another video clip.